Okay, first program we're going to look at is this one, the bit shifter program. You can see what files it includes. It's pretty standard for my console applications. Now let me first run this so you can see what the program does. You know, taking a number, an integer, 5225, and then it's showing you what the binary representation of it is. So, but basically you have the show bits function here that accepts an unsigned integer. You know, it returns void, so but now we have, you know, integer I. The funny thing is that we're not really passing an unsigned integer, but I don't think we're doing any type conversions or anything. But this is treating it like an unsigned integer when we pass it in. So, which really isn't necessary. I mean, I don't think. Shouldn't be. I mean, a binary number, you know, representation of that would just have a 1 in the most significant bit position. But at any rate, you know, see, even inside here, it's just, you know, using I as an integer. But again, that still may filter the sign bit off of that. I don't know. Well, it really won't filter it actually. It'll still be on there. It'll just bring it in, but it won't treat it as a sign. So, but then again, when we create an integer I, well, this is just for counting purposes. So, you know, integer x, you know, is a local variable that's been created, which is unsigned. So it'll treat the, you know, the number as an unsigned value, which is good. You know, so it won't screw with our program. But anyway, we set up a for next, or, you know, for loop basically, and it's based on the size of an integer, which an integer in C here is, you know, 4 bytes. So let's take 4 bytes and multiply it by 8 bits, okay, to give you 32 bits. Then it's subtracting 1 from it. Then it's going to increment until it's greater than, I is greater than or equal to 0, and then it's going to post-decrement the counter, so it'll be counting down the I bits. But then it's, you know, taking x and anding it, okay, you know, with an unsigned, I don't know where I got this program, but 1 unsigned, and it's left shifting it by I. Okay, then using the ternary operator to either put you know, put character function puts the character to the console. So it's putting either number 1 or 0 to the console, you know, depending upon the result. So, okay, but I know our, you know, for loop is going to shift 32 times, so we're backing this off by 1, you know, to start with. So start at position 31, and decrement down through it. And what this function does is taking 1, again, I don't know why they have to specify unsigned integer, because that's what that U means. See, you know, unsigned int, 1U. But anyway, I guess that just ensures type compatibility or some shit. But, you know, again, we're starting, you know, at 31, but it's basically, you know, 31, it's going to shift this I, you know, or this 1 rather, you know, by I bits. So, but this is an integer, so it's an integer of value 1. You know, that means it's 32 bits, you know, with the least significant bit set to 1. Okay, but it's going to shift it, you know, starting with 31 characters, but then it'll be 30, and then 29, and 28, etc. And each time it's anding it, so this is just a bit mask is what it is. So it'll and it, you know, and if a particular position, happens to be greater than 0, okay, then this condition will be true, so it'll put a 1. If it's not true, in other words, there's a 0 at that location, and they ended that with a 1, well, that's going to, equal 0. So, it would execute this. So, and then whoever it did, is using printf, to print a new line character. And here's the number we're starting with, and all the variables here are integers initialized. Printf, that's a decimal value, or not decimal, but I don't know, just an integer or whatnot. That's %d, is what I'm saying. When they're doing a tab character, they're going to do it twice. /t/t. Well, I don't think they need to do it twice. There's just 2 tabs in there, apparently. Anyway, but, j is our variable that we're printing, so, anyway, then we're calling our showBits function, so it's passing j to that, okay, which extracts the binary. Okay, and then we go down to this for loop down here, and it says, m, I guess that's m equals 0 to less than 5, less than or equal to 5, m plus plus, so it's post-incrementing the m, and it's saying basically n equals j shifted right m times. So it'll do 5 bit shift positions on it, but each time it'll go print this statement, which you can look these decimals up and see what they are out there, or %ds, percent character functions. I forget what they call them, but anyway, it'll print this out, okay, and then call our shiftBit function, for every n that it sets equal to that shifted version of that. So, and then the system pause is just so the console, because in debug mode it'll just stop out. If you put it in run mode when you run it, I don't think this is necessary, but in debug mode it is. Otherwise the window would just stop out. But at any rate, you can see pretty much what this is doing. So, pretty self-explanatory, but still pretty cool little algorithm.